the heart, of course, sits there. Next thing you have is the pericardial sac. We don't have a really great shot of the pericardial sac, but what you'll see, and hopefully we'll find one, if you find a fairly large, thin flap, and it won't stick out too much. Are any of the TAs still in here?
Yep. Mm-hmm.
Can you guys find maybe another heart that might have the pericardial sac on it? Just a flap, and I'll show them, but this is a little bit of it right there. It's going to be opaque. When we say opaque, it means you can't really see through it, as opposed to translucent means that you can see through it. So the pericardial sac would be this thing right here. And then, of course, this is going to be...
It's right here.
You have one? Did you find one?
Sorry.
Oh, great. Thanks, Kevin. So this is a great shot of a pericardial sac, still intact. It's going to be relatively opaque, which means you can't see through it. Part of it here is translucent, which means you can kind of see through it. I can see Jacqueline a little bit right there. But this is the pericardial sac. It's made of 2 layers. Now let's go back for a second. Remember, we've got a visceral and a parietal layer of all this stuff, don't we? Whether it's peritoneum, pericardium, or pleura, right? So this is the pericardium because we're talking about cardia, which means heart. So this is the outer, okay, this is outer. This is going to be the parietal pericardium. And then this is going to be the inner, the visceral pericardium that lines the surface of the heart. So there's 2 layers to this though. The parietal pericardium is the inner layer, and then the outer layer of this, which is a little thicker, is going to be the fibrous pericardium. The fibrous pericardium, if you remember from lecture, was going to be, we talked about this earlier in the semester, fibrous pericardium was made of collagen fiber, was non-expansile. This is pretty tough stuff. So the pericardial sac is made of the parietal pericardium and the fibrous pericardium, okay? That's this thing right here, pericardial sac. And then it goes inward and becomes this thing that's on the surface of the heart. This is the visceral pericardium, okay? And it is translucent, means you can see through it to see the heart tissue below, and of course the fat as well. This visceral pericardium is also known as the epicardium. So the inner lining of the pericardium is the same thing as the outer layer of the heart. So if you fold this open, you can see there are 3 layers of the heart. There's the outer one, the the visceral pericardium or epicardium. Then the middle layer, which is going to be all this stuff here, which is muscle. We call that myocardium, which is muscle, right? Muscle heart. And then the inner layer, which is going to be this kind of creamy, milky kind of layer, which is going to be the endocardium, the inner layer. So those are the 3 layers. So the visceral pericardium is the same thing as the epicardium. The inner layer of the pericardium is the same thing as the outer layer of the heart. Okay? Epi, outside, surrounding the outside. Next thing, we covered visceral pericardium, we covered epicardium, we covered myocardium, endocardium, coronary blood vessels. The only thing we would ask you on the coronary blood vessels is, and they, by the way, they're going to set in this, in these little areas of the fat. There's a coronary blood vessel there. You can kind of see it when you look. There's a blood vessel in there. Okay, blood vessel in there. One thing I forgot to mention, the other group, which is kind of interesting with this group, is you'll notice that those blood vessels have fat deposition around them. The reason why, this is really cool. The reason why is because the heart is the only aerobic tissue we have in the body. Okay? There's nothing else in your body that is truly aerobic. What does that mean? It's got to work all the time. Okay? If it doesn't work all the time, we're dead, aren't we? So this has to work all the time, so it's truly an aerobic muscle, isn't it? Well, what do we know about aerobic activity? Well, it likes to use fat as an energy source. So it makes sense that this deposition of fat is close to the blood vessels that supply the heart with their energy supply. People have always asked, well, why is all this fat on there? Because it's an aerobic muscle, it needs fat. Okay? It doesn't use a lot of sugar, it uses fat. Alrighty?
Where would the fat be deposited from the thymus? You said?
Well, fat just simply infiltrates where the thymus was.
Okay.
So if you don't have a lot of body fat, you're not going to see a lot of fat in that area. Okay? So all we would say, there's a coronary blood vessel there, coronary blood vessel there. We're not going to go any further than that. In lecture, we'll explain the coronary arteries, vessels, but we won't do that here. Right and left atrium. So when we open this up, remember the right side of the heart pushes blood to the lungs, the left side of the heart pushes blood to the body. So let's open one up, we can see a little bit better here. Okay. So if you look at this heart here, this heart shows the right and left sides. We're going to go to the ventricles. The atria are a little bit harder to tell, but the ventricles are really easy to tell. The thinner walled, okay, so this is a ventricle right here, ventricle right there, so the thinner wall is going to be the right side. The thicker wall, and you can look here, you can see, this is actually the surrounding of the left ventricle right here, and the right ventricle looks like a sidecar on the side of the motorcycle. Okay, so this is right ventricle, this is left ventricle. Thicker wall left, thinner wall right. Okay, you with me? And the other reason I explained to the group on Tuesday was that we see the thickening, the difference in the thickness. Is if you look at my body, I'm a 5'8" column of water. Okay. To send blood to that entire column of water, I've got to send it down. Anybody disagreeing with me being 5'8"? I didn't think so. So if I have to send blood all the way down to the ground, and then I got to push that blood from the ground all the way back up, I've got to push that blood against gravity. So I have to have enough pressure to push the blood down, which is easy. Gravity assists that. But the real function of that heart being forceful is to push the blood back up to the heart from the feet, let's say, for instance, against that the gravitational forces of me being a 5'8" column of fluid. That takes 120 millimeters mercury pressure to do that, 120 over 80, doesn't it? You've all heard that term before, haven't you? Blood pressure, 120 over 80, that's supposed to be normal, isn't it? Okay, but what you may not know is that this right side of the heart has to push blood to the lungs, right? How tall are the lungs? Well, they're this tall, about 30 centimeters tall. So 30 centimeters tall as opposed to, I don't know however tall, I'm 160 centimeters tall there. So 30 centimeters here, a lot taller here. So I don't have to push the blood very far down or very far up. So the resistance to blood flow back to the heart from the lungs is very low. So the blood pressure, if it's 120 over 80 here, it's about 25 over 8 on this side. Can you believe that? Okay, that's what Guyton says. Guyton was a medical doctor who wrote medical physiology, one of the gold standards for medical school physiology. So that's the reason why the right side wall is so thin compared to the left side wall. Okay, so now let's see, right and left atria the left atria is up here. That's left atrium. We're going to go into a little bit more depth later. And then the right atrium is actually up here on this side. Actually, no, sorry, it's right here. So we go above the right ventricle. That's the right atrium where I'm sticking my thumb right now. Okay. We covered the left and right ventricles. The auricle. So I always say this, my TAs have heard me say this millions of times, but the auricle is this structure right there. OR is auricle, AUR is auricle. So OR is, of course, the soothsayer that Keanu Reeves had to talk to in The Matrix, right? Yeah. So that's an auricle. But auricle, AUR, means ear. And if you look, you can see it looks like an ear flap, doesn't it? Ear flap. We see another one over here. So the two atria each have an auricle. We'll cover in lecture what their function is, but that's where they are. You can see auricle here, auricle right there. Okay, they all have auricles. Pulmonary trunk. So I cut one of them open. So I don't know if this is the one or if it was a different one that I cut. But the pulmonary trunk, none of these have been, I don't think any of these have been cut. So anyway, this is the way we find the pulmonary trunk. What I want you to do to find it, get your bearings, we can get our bearings really easily. We say this is left side, that's right side. You agreed? Mm-hmm. So what you want to do is you want to take your right side hand, your right pinky, and you're going to slide it up, and you're going to orient it so the heart is the right side towards your right hand, left side towards your left hand. Okay? If I flip it like this, it's opposite, isn't it? So right to right, right to right. Take my right pinky, I'm going to slide it right up in here like this in the right ventricle, and it is cut. Where I come out right there is the pulmonary trunk. That's pulmonary trunk. If I do the same thing with one that's not been cut, here we go. Okay, right, slide my finger up in here, and this is a little bit smaller, but I'm going to come out through that little hole right there. That's pulmonary trunk. Okay, that's pulmonary trunk. So the aorta, so here's what we do with the aorta. This is the left side, okay, left side ventricle, left side atrium. So this is atrium up above. We're going to come down like this, and then we're going to go up in this direction. So blood comes down, and then it gets in here, and then it goes up and out. Bless you. So from the left ventricle, I'm going to go up through this hole, and this hole is the aorta, okay? There's the aorta. See the blue? That's aorta. And where's Alex? Tall Alex. There's Alex. So Alex, right there, there's aorta, and that's the brachiocephalic trunk that we were talking about, right?
Okay.
So that's it right there. If I move over just a little bit, oh, I just tore one of the I'm not going to go up in there, but that's the brachiocephalic trunk. Push my finger, I'm touching my finger there with the probe. Are we good? I don't want to do too much because I'm tearing part of the valves in there. Let's see. Ligamentum arteriosum, you can scratch that out. I'll say it again, you can scratch ligamentum arteriosum out. Aortic semilunar valve. So aortic semilunar valve, remember the semilunar valves are the ones that go either to the lungs or to the body. So the aortic semilunar valve is this valve right here. So there's the ventricle. The aorta is going this direction. So this is part of the aortic semilunar valve cusp. See that thin membrane right there? Some of it here, some of it there. That's the aortic semilunar valve cusp. If we go to this one, again, here's the aortic semilunar valve cusp. The aorta is right there. Okay? Then that's it right there. That's another little flap of it right here I have a hold of. The other flap is this, it's actually, it's right here. So those are the three. 1, 2, and then the other one is this third one, which has been kind of torn right there. 3 of them. All the semilunar valves, well, I should say both semilunar valves have 3 cusps to them. Pulmonary vein. So the pulmonary vein, I just told you. Okay? So pulmonary trunk, same thing as pulmonary vein. We're going to put right with right. We're going to go up like this, and the pinky finger is going to go out through pulmonary trunk, pulmonary vein, which is right there. See it right there? See it? Okay. Strike a pose. Okay. Superior and inferior vena cava. All right, this is the way we like to do superior and inferior vena cava. You can line it up like we did again, right with right, left with left. Okay? Actually, no, we're going to do the opposite. Sorry. This is a better one to use. So now we want to have the right with the left. So left hand, we've got the right side of the heart. So this is where we're going to find the right atrium, up in here. You won't find it up here. This is how we leave the right ventricle. Okay, that's the pulmonary trunk. We don't go right with right here. We go left hand with right side of the heart. So we go up here. That's the right atrium. So the 2 vessels that enter the right atrium will be the superior vena cava. I'm going upward. See how I'm going upward here? Superior vena cava. I'm going to drop down and go this direction. There's the inferior vena cava. Okay, so go up, superior vena cava. Go laterally, inferior vena cava. And what I like to do is I'll stick a probe in here and connect the 2. And basically the way the heart sits inside the body, okay, sits inside the body well, it actually sits more like this, kind of like this inside the body. So here's the superior vena cava, and there's the inferior vena cava. See that, Anna? Okay. Right AV valve, tricuspid valve. So these are easy. Tricuspid valves and bicuspid valves have the same, I forgot to do the structures for this. I'll have to do this for you all. Forgot to do that, didn't I, TAs? Yep, forgot to do it. So this is the valve between, so this is the left side of the heart. This is the valve between the left ventricle and the left atrium. So this is on the left side, this is the bicuspid valve. The bicuspid valve have these long, thin structures. These are called chordae tendineae. And they attach to the side of the heart wall via the papillary muscle, which is down below. So the valve cusp is up here. Chordae tendineae are these cord-like structures, tendinous cords, papillary muscle down below. On the other side, here are the chordae tendineae. Okay, this is still part of the left side. This is still bicuspid valve. Here's the valve cusp, chordae tendineae, and then the papillary muscles where it attaches right there. On the right side, we have the same thing. So this is the tricuspid valve, valve cusp, chordae tendineae, and then the papillary muscles right there. I got to cover those before you all leave today. I'll do a little lecture on the board. Pulmonary semilunar valve, we talked about that. We talked about, oh no, we didn't talk about pulmonary semilunar valve, so let's go to that now. Again, pulmonary semilunar valve, that separates the right ventricle from the lungs as we go up through the pulmonary trunk. So we're going to go back to the right and right again, right to right. We're gonna go up like this. Okay, there's your pulmonary trunk, but I cut this one last time so we could open up and show you the pulmonary semilunar valve cusps. See those little thin, wispy structures right there? See those? Yes? Those are the, I'll turn it towards you guys as well. Those are the pulmonary valve cusps. So on this side, if you look in there, you can see valve cusp kind of right here, valve cusp right there, and there's a third one over there. So those are that's the pulmonary semilunar valve. Okay, did you see it as well over there? Kind of? Carolyn, did you see it? Okay. So it's again, it's going to be those little thin flaps right there. Emmy, can you see it? Interventricular septum is easy. Inter means between the ventricles, right? Septum is a divider. So this is the interventricular septum here and septum right there. Okay? Divider between the two. I miss teaching advanced phys because I would talk about how this whole thing works. It's very cool. Coronary sinus. So this is one that's hard for most people to find. Again, you got to get up into the right atrium to find it. So let's go back to the position we want to get to. Remember, to find the right atrium, we put left hand with right atrium. To find the pulmonary semilunar valve, we do, or trunk, we do right hand with right hand, or right hand with right heart. So we're going to flip it like this. We're going to go up in here. All right? We're going to go up, and remember, I took the pinky and I went up, and I found my superior vena cava. Superior vena cava going upward. Yes? What I'm going to do to find the coronary sinus is I'm going to drop down and go take a right angle and go right in like this towards the heart, towards the center of the heart. And I will show you when I open that up. Hopefully we can see it in this one. And then, so I'm going to go, this is going to be going up through superior vena cava, upward through superior vena cava. There it is. And we're going to go sideways to get into the coronary sinus. So there's the hole for the coronary sinus right there. See it? That's the hole. That's the hole. Oops. That's the hole right there, going in towards the heart. Yes, you see it? Superior vena cava is up above. Coronary sinus is more medial. See that? So now you've seen where we go in. Now I'm going to show you what it looks like on the outside. This is kind of cool because there's a blood vessel that we're now entered into with the coronary sinus. That's the great cardiac vein. You see the probe sticking out against that? I'll go back in. See the probe? Yes? See the probe right there? Pushing against it? We're inside this vein. See it flowing along the inside? You guys see it over there? Did you see it, Alex? Okay, Jacqueline. So there it is right there. So the analogy I like to use is a trumpet analogy. So that, what I just had the probe in right there would be, that's the great cardiac vein, that's like the coils of the tubes of the trumpet. And then the flared open, the horn that comes out, that allows the air to come out, that wide flared open area would be the coronary sinus. So the bell or the flared open area would be the coronary sinus, and the tubes would be the great cardiac vein. So what does the great cardiac vein do? It takes blood from the heart muscle tissue and brings it back to the right atrium. Okay, dumps it in the right atrium. Makes sense because if we send blood to the heart, we got to bring blood back from the heart. If it goes to the heart, we've got to reoxygenate the blood coming back from the heart. So where does it need to go? Into the right atrium, which is where all the other blood comes from the body back to the heart. Okay? So that's coronary sinus. Papillary muscles, we talked about those. Chordae tendineae, we talked about those. Left AV valve, or the bicuspid valve, of course, that's the bicuspid valve right here. Okay, between, remember the bicuspid is the left side, try before you bi, right side to left side, right? Best observed on the sheep heart. So that's everything on the sheep heart that you need to know. Are there any questions? All right, so very quickly, I want to go up on the board. I'm going to do a very quick lecture and talk